Hello and welcome for the today's discussion. Myself Vishwanath Avti, and today we will discuss about frequency of irrigation, and we'll discuss some of the problems, and we'll see that some important questions from previous year question papers. So first we should understand what you mean by frequency of irrigation. So frequency of irrigation refers to number of days between irrigation periods during without rainfall. So it is number of days between irrigation. It is number of days between irrigation or time interval between two successive irrigation. Time interval between two successive irrigation. Frequency of irrigation is controlled by the amount of available water contained in the root zone, of soil and consumptive use rate, right? It depends on root zone of the soil as well as consumptive use rate. If D is the root zone depth in meters, right? If D is root zone depth, right? And FC is the filled capacity, FC is the filled capacity, and MO is the lower limit of readily available moisture content. MO, right? These are very important. Is lower limit of readily available moisture content. Depth of water to be given during each watering is found from the following expression. Right here, dW. dW means what? It is depth of water to be given during each watering. Right? How much water we have to give? It is a minimum depth. It is calculated, and that calculated by lambda d. It is a dry unit weight of soil to lambda w, right? It is a unit weight of water into D and into Fc minus Mo. So once again, dW is depth of water to be given during each watering, and lambda D is dry unit weight of soil, and lambda W is unit weight of water into D. So D um, is root zone depth, and Fc is filled capacity, and Mo is lower limit of readily available moisture, right? So then if Cu is daily consumptive use rate, frequency of watering Fw is given by. So then frequency of watering or frequency of irrigation is calculated by dW by Cu. So then dW is what? Depth of water to be given during each watering, which is calculated using above formula. Then Cu, consumptive use rate, right? Very simple formula. These two formulas are very important to solve the problems. Next, the time required to irrigate a certain areas. So how much time is required? Let T be the time required to apply the desired water depth. So for to desired water depth, how much time is required to bring water level in the soil from minimum water level, readily available water level to filled capacity, right? It is a time required uh, to bring water level in the soil from MO to field capacity Fc over irrigation field of area A. So even they have given area under the area. If Q is the discharge in a field channel in Qmax, we have equation that is T equal to A into dW by Q, right? So area is in hectares. Area, right? Area is of irrigation field area. dW is the depth of water given for watering, and Q is the discharge, and T is the seconds. So we can calculate time in seconds using this formula, where A is area in square kilometers. So in this equation, area is in square kilometer. dW is the depth of water to be applied in meters. So both are in area is in square meter and dW is in meter. If however area is expressed in hectares, if area is expressed in hectares, then same formula is reduced to this, right? It is dW by Q, A into 10 to the power 4 because it is converted from square meter to hectares, right? So that's what you will get the formula 2.778 ADW by Q hours, right? It is in terms of hours, right? Okay. So we'll see some important problems, right? The same problem is asked in December 2016 and January 2017, right? So we'll see after how many days will you supply water to soil. Means it is the frequency of irrigation. They are indirectly they are asking what is the frequency of irrigation or interval of irrigation in order to ensure efficient irrigation of the given crop. Right? It is what in order to ensure efficient irrigation of given crop if field capacity of soil is 27%, permanent wilting point is 14%, dry density of soil is 15 kilonewton per meter cube, effective depth of road zone is 75 centimeter, daily consumptive use of water for the given crop is 11 mm, right? So be careful about units, right? So then first we have to calculate available moisture. So to calculate available moisture, we have a formula. It is field capacity minus permanent wilting point, right? So then a field capacity is already given 27% and permanent wilting point is given 14%. Then we are getting 13% as the available moisture, correct? But let the readily available moisture be 80% of available moisture. So available moisture is 13%, and out of 13% only 80% of available moisture, right? So then readily available moisture is equal to 13% into zero point 0.8. Why? Because only 80% readily available, right? So out of 13 only 80% is available. That's what it is taken as 10.4%, right? 10.4%, correct? Okay. So then MO, readily available moisture, is equal to 27 minus 10.4, right? So it is what field capacity minus earlier calculation, right? So that is we are getting 16.6 percentage, right? Hence when irrigation water is applied, moisture is raised from 16.6 to 27%. Depth of water stored in road zone during each watering, that is dW. So dW is equal to as a second formula. Then we have to substitute the values. So it is what delta D. It is a dry unit weight of soil, right? It is given, right? How much is given? 15 kilonewton per meter cube. Substitute. Then D is given. It is they have given 75 centimeter and converted in meter 0.75. Then unit weight of water. So unit weight of water is 9.81, right? You can see in the note. In the note, density of water is 9.81 kilonewton per meter cube. Then field capacity minus readily available moisture, right? So they are taken in terms of fraction, right? And then you will get 0.104, right? Then you will get answer dW in terms of meter 0.119, and if you convert into centimeter you will get 11.9 centimeter, correct? Okay. So then depth of water available for evapotranspiration is 11.9 centimeter. Daily consumptive use of water they have given 11 mm, but it is in centimeter 1.1. So then frequency of irrigation or water frequency equal to it is what dW. It is depth of what available depth of was depth of water in each watering, right? Which is calculated in terms of centimeter, 11.9 centimeter divided by consumptive use of water 1.1. So then you will get in terms of days 10.82 days, and approximately is equal to 10 days, right? Hence the water should be applied after every 10 days interval. So we'll go for next problem. It is also asked in June July 2016. Okay, the difference is they have given density of soil in terms of kg per meter cube, right? Okay, we'll see. The following data pertains to healthy growth of crop. Field capacity 30% they have given. Permanent wilting point they given 11%. Then they given density of soil 1300 kg per meter cube. Effective depth of root zone 700 mm. Daily consumptive use of water for given crop 12 mm. Right? For healthy growth, moisture content must not fall below 25% of the water holding capacity between field capacity and permanent wilting point. Determine water interval in days. So they are asking determine water interval in days. Correct? Okay. Water interval means it is a frequency of irrigation. Right? So we'll see how to calculate. First, water holding capacity of wilting point. It is what? Field capacity minus wilting point. Right? So field capacity they have given 30%, and permanent wilting point they have given 11%. It is means available moisture. We are calculating indirectly available moisture, that is 19%. Out of 19%, it should not be less than 25%. Right? Fall means 75% is readily available. Right? It should not be 25% less. Right? You can see it for healthy growth moisture content must not fall below 25% of water holding capacity between field capacity and permanent wilting point. Correct? So then how much is readily available? 75% is readily available. So that's what readily available is 75% into available moisture. So then same procedure, but they have solved the two steps in single step, right? So that is filled capacity minus 0.75 into 19, you will get optimum moisture or readily available moisture is 15.75%. Correct? So then we will calculate uh, depth of depth of watering, right? DW, right? So then same formula we are using, right? So substitute the given data. First substitute the density of soil 1300. Then substitute unit weight of water, right? 1000. Then substitute depth of road zone 700. Correct? So then field capacity 30% means 0.3. Then readily available moisture MO is 15.75 percentage, means in fraction it is 0.1575. So then depth of watering you will get 1 to 9.68 mm. So it is in terms of mm. So earlier we calculated in terms of meter, now it is in terms of mm. Correct? So daily consumptive use is 12 mm. Then water interval, right? So it is what? dW by consumptive use, Cu. So dW is 129.68. Then divided by consumptive use, that is 12. So then we are getting 10.80. So approximately equal to 10 days. Okay. So next problem, it is not for frequency of irrigation, but they may ask some questions because almost it is related to frequency of irrigation, but they will give frequency of irrigation, they will ask to calculate daily consumptive use, right? We'll see. A certain crop is grown in an area of 3000 hectares, which is fed by a canal system. The data pertaining to irrigation are as follows, right? So field capacity of soil they have given 26%, optimum moisture content 12%, permanent wilting point 10%, effective depth of root zone 80 centimeter, and relative density of soil 1.4. If frequency of irrigation is 10 days and overall efficiency is 23%, find daily consumptive use and the water discharge in meter cube per second required in canal feeding the area, right? So here they have given area, they have given permanent wilting point, they have given optimum moisture, they have given, means MO is given, then permanent wilting point is given, effective depth of road zone D is given, relative density of soil SG is given, and frequency of irrigation, right? FW is given, right? So we'll see how to calculate daily consumptive use. Same formula we are using to calculate daily consumptive use, that is it is dw by see, we are using the formula, frequency formula, that is dw by fw into consumptive use, right? So then we'll see how to calculate. So dw equal to sg into d bracket fc minus mo. So we know what you mean by fc, it is a field capacity, and mo is optimum moisture, it is the lower lower limit of, it is a readily available moisture, right? And D is effective depth of road zone, and SG is relative density of soil. So relative density of soil is given 1.4, then D effective depth of road zone is given 80 centimeter, substitute 80, correct? So then field capacity they given 26, means 0.26, then optimum moisture 12%, 0.12, and if you calculate you will get a depth of watering 15.68 centimeter. It is in terms of centimeter. Then frequency of irrigation is 10 days. So use the formula frequency of irrigation, that is FW equal to dw by cu, right? But now we are calculating consumptive use, means cu. So that's what we'll get frequency of irrigation in lower, right? So that's what dw, that is 15.68, and frequency of irrigation 10 days. Then you will get daily consumptive use of 1.568 centimeter. You will get in terms of centimeter, and it is in terms of mm, 15.68 mm. Then total water required in 10 days. So area they have given, right? So then area into dw. So area is 3000 hectares, and it is converted in meter, 10 to the power 4. Then dw, it is in centimeter, so centimeter to meter, right? You will get total water required in 10 days, right? You will get this value, right? So then discharge in canal, second calculation, it is total water required for in a 10 days divided by seconds, right? It is converted in seconds, 10 days into 24 hours into 3600 seconds, right? So then you will get in terms of cumex, meter cube per second. So we'll see important questions. So here in 2018, January 2019, there is a question, write a short note on frequency of irrigation for 3 marks. Then December 2016 and January 2017, there was a problem, right? And which we solved, right, in the previous problem, first problem, right? So go through the first problem, and it is same as 2016 Jan 2017. Then in June July there was a problem, and it is also solved as a second problem, right? Okay. So then December 2015 and January 2016, same question, almost same question, but there is a change is density of soil. So density of soil they have given 1.5 gram per centimeter cube, right? So that's what here also I given density of water 1 gram per centimeter cube, right? Okay. So then go for next problem. Here also instead of they have given in a sentence format, all the same data have given, whatever data is required they given, and even they have given density of soil 1.5 gram per cc, right? So then they have given road zone in 70 centimeter, right? And they have given, assume that readily available moisture is 75%. 75% means 0.75 of available moisture we have to consider, right? Okay. So for this I used mainly Dr. B.C. Punimia textbook of irrigation and water power engineering, right? And even you can follow Dr. N. Balasubramania textbook. Thank you.